What's up everybody, my name's Scott, and in this video we're going to be setting up the coilovers for the Locost chassis. The suspension on this car is very similar to other Locost 7s and pretty similar to the original. Each lower control arm and upper control arm combination requires the builder to size their coilovers based on vehicle weight and the lower and upper control arms. I've already mounted a plate down here on my lower control arm, which is where my lower shock tabs are going to mount. You need 3 measurements. You need the eye-to-eye distance that your coilover is going to be at ride height, distance at your maximum bump, distance eye-to-eye on droop. The process to get those dimensions is pretty straightforward. Basically, the first dimension, which is what they call mount length on a coilover, is just eye-to-eye at ride height. So you basically set the chassis at whatever ride height, you make sure your lower control arms are where they're going to be, take a measurement. And I got 12.75 mount length. The next dimension is the droop. So I did 3 inches of droop. How you do that is you raise the front of the car 3 inches, suspension sag all the way down, and then you measure, the same locations, and I got 14 and 5/8. Did a 2-inch bump, so you raise the suspension, the wheel traveled 2 inches above ride height, and I got 11 1/4 inches for a length on that. So I have my lengths wooden template on my laser, and then trace out shock tabs. 2 of these tabs are going to go on the lower control arm, and they are going to hold the shock to the lower control arm. And I'm using this brake fluid bottle, which is basically a 3.5 inch diameter bottle, and I'm mocking in the locations of this upper. There's a little bit of a clearance issue to this tab, but that's not a big deal. I'll be able to trim that down for clearance. I'm pretty happy with the lengths that I've established. So I need to cut basically what is a mock-up of the shock. For drilling holes, I like to use a 1/2 inch end cutting end mill. It just makes it a little easier in this small mill drill. So now I got 2 holes that are 12 3/4, so that's the exact mount length. Alright, here's the setup. I've got the 1-inch tube and 2 spacers, and then everything's lock nutted on. So a little tricky to get the exact perspective, but the top of this is basically directly in line with the lower control arm. So if I measure from what I think would be like the theoretical center line of this tube, I've got 2 inches to these arms, which means I should be able to fit a 4-inch diameter spring, or 3.5 with good spacing around. So that checks out with what I want to do. One of the last things I want to do is check the angle. And this is not by any means a great indicator of performance, but something to verify. So right now this thing's currently saying I've got a 55-degree angle, which is, from what I understand, pretty good. You want to try to keep this mount out as far as you can, and you want to try to keep this at greater than 45 degrees. All in all, I think this suspension setup is coming out really good based on what I got out of the computer program that I used and where these mounts and the locations are going to end up. I think the only thing that worries me is the diameter, outside diameter. So I think at this point I'm going to get the welding machine out, and I'm going to tack these lower mounts in. So after a bunch of measuring and a couple different clamps up here holding everything together, I'm going to tack weld this side in. This bar has kind of become like a fixturing point for the suspension, so I'm going to put some tack welds across it to hold it in place. And that's just going to help me make sure that the bar doesn't get knocked loose, because I am fixturing my upper shock mount locations off that bar.